All right, next let's look at complex fractions. So a complex fraction is a situation where you have a fraction within a fraction, right? Or sometimes multiple fractions within a fraction. And so the basic idea with complex fractions is we want to try to get this to be one fraction, and then, in other words, simplify the numerator, and if you can, simplify the denominator as well. And then once you do that, then you can divide the numerator by the denominator, and then hopefully that will simplify some more. Okay, now the issue with this is if I plug in a -3 right there for x in the denominator, I will end up with a 0 in the denominator, and that means it's undefined at that point, so I cannot directly evaluate this, right? But hopefully by simplifying this complex fraction here, we'll be able to get to a point where we can directly evaluate. All right, so the first thing I'm going to do is I'm going to get a common denominator here in the numerator, right? So I have this 1, so I'm going to make it 1 over 1, and then I see that I have a denominator of x plus 2 here. So what I'm going to do is I'm going to multiply by x plus 2 on top and bottom with that 1 over 1, and that'll get us a common denominator here, right? So we'll have the limit as x approaches -3, and then the numerator will have 1 over x plus 2 plus, and now I have x plus 2 over x plus 2, right? And then I have that x plus 3 on the bottom. All right, and so now I can combine this, and we can do some of this work just up here so we don't have to rewrite everything again. But what we'll have is, now that we have this common denominator, we can combine 1 plus x plus 2, right? So I'm combining the numerators all over x plus 2, right? And so basically, just like we do with all fractions, once we get a common denominator, we combine them, the denominator stays the same, and then the numerators we just add or subtract, or combine like terms. And so here we can see that 1 plus 2, those are like terms, so that'll be 3. So it'll just be x plus 3 there. Okay, that's what this turns into. And then that's over x plus 2, this, right? And then all over, and then that x plus 3 is still on the bottom. Okay, and then of course we still have the limit as x approaches -3. All right, so now that I have this as a single fraction, now I can divide and simplify even further. So this is going to be the limit as x approaches -3, and then I'm going to do x plus 3 over x plus 2, so the numerator fraction, divided by, and when we divide, what we do is we multiply by the reciprocal of the denominator, right? Or the reciprocal of the second fraction. So what I'm going to do is I'm going to multiply by 1 over x plus 3, right? So remember, when we divide fractions, we flip that guy, this guy, and multiply, right? Flip that guy and multiply. And so that's what we're doing right here. Okay, and so what happens is these x plus 3's cancel out, and we end up with the limit as x approaches -3 of 1 over, if we multiply top times top, this is an invisible 1 there, so 1 times 1 is 1, and then here this turns into a 1 as well, so we get x plus 2 times 1, which is x plus 2, and so we end up with that fraction, not complex anymore, and even more importantly, it's something that we can use direct evaluation for. So if I plug in -3 there, I'm no longer going to end up with a 0 in the denominator, and so I can actually directly evaluate this now. So it's going to be -3 plus 2, and that turns into -1 on the bottom. 1 over -1 is just -1. All right, so even though we couldn't directly evaluate this, we found algebraically that the limit as x approaches -3 of that function is -1, right? Okay, and remember, by the way, we've been working with these algebraic methods, but remember that we could also do, we could use a table if we wanted to. We could use, we could evaluate the graph if we had a graphing utility available to us, and so there's a few different ways we could do it, but this is the way we can do it algebraically, in case we don't have a calculator, right, and it's not easy to get the table and or the graph. And to reiterate, now we went through all three of these possibilities, right? We talked about factoring and canceling, right? Factor and cancel. We talked about multiplying by the conjugate, right? And then when we have square roots, okay? And then the last one we did was when we have a complex fraction, we simplify it, right? And that's what we just did on this last one.